Hello, so today we're going to be talking about Big O and what it means and why it's important to us as programmers. So first off, I'm going to start by explaining time complexity and how that all relates to this. So when you first think of time complexity, especially in the context of coding, you probably are going to think about how long it takes for your code to run. However, that is actually not the case. Time complexity is actually the time taken to execute the statement of a code. In other words, how many times a statement will execute. And you're probably asking yourself, so how does this relate to Big O? Well, as programmers, we measure time complexity with Big O, and there are different time complexities like the ones you see here on the graph. And there are obviously better time complexities and worse time complexities. And basically, as you can kind of see the difference between these three and these three here, this is more like O of n, O log of n, and n log of n are more of like a linear growth and a linear relationship between the size of data and time to complete, whereas this is more of an exponential relationship. And the reason you want a linear relationship is because obviously as the size of your data increases, you want the time to complete or the execution time to grow at a linear rate, right? And because if it grows at an exponential rate, like these time complexities here, then that just means that your execution time is really slow for the small amount of data that you have. And yeah, I mean, that's kind of an introduction and explanation I had for Big O. So here I'm going to explain different functions and their time complexities. So this is O of 1, and it's O of 1 because I'm just getting my head, so I know what I'm getting, and it's a definite size. And I'm only returning exactly what I need. So definitely just O of 1. This is O of n because I am basically printing through my linked list. And so basically what I'm doing is, if this is my linked list, this is what I'm doing here. And you can just see that this is obviously a linear time complexity. It's just it's just O of n for that then. And you can kind of just visualize that it's O of n because it's just printing out 1, arrow next 2, arrow next 3, arrow next, and then obviously null. And this is O n log of n. So outside, this is O of n. So like any for loop is really O of n because you're just printing out like 1, 2, 3, 4. But if it's a nested for loop, and has something like divided by 2 times 2, then it's log of n. So on the outside it's O of n, and the inside is log of 2 of n, I think. And so you just drop the constants, you just do n log of n, so O n log of n. And O2 of n, so for recursion, there's like this usually a pattern, so how many times you call your recursion function, it's that many times the power of n. And you can kind of trace it. It'll look something like this. So you have 5, right? So it'll be 3 plus 2. No, let me stop. 3 plus 4. And then you'll go to the 3, and it'll be 2, and then 1. And then it'll be 2, 4 minus 2, 4 minus 1, 3. And so as you can see, it increases by 2 every time, so 2 to the n. So that's why that's like that. Oh, my bad. And then for here, log of n, kind of like what I was saying, it's a for loop, but it's has something here like I times 2, or I, divided by 2 perhaps, is just O log of n. And then for my n squared, I have a nested while loop, and it's the same thing as a for loop. So one for loop is O of n. If it's nested, then it's O of n squared. So yeah, that's Big O for you.